Hello. So today I would like to finish up this kana stats command, and we will start off by fixing a problem which I noticed when I was tinkering with it offline. So there is it doesn't recognize this certain character called the choon kigo, or the character which indicates that the previous vowel is to be extended. So this is added here, right here on this line. Now this character, we there's a point where we get right here. We check we check this. We if something is not katakana or hiragana, then we give a bug report. So that is a problem. And I think that what I want to do is I want to count this character as katakana. And so in order to do that, I will first write a test. And this will be, we will basically populate the right-hand column. In other words, a katakana column. So, cho, like that. And let's do make. Okay. I want to do it in only one job. Okay. Now, okay, so the failure is all the way down here. So we'll do is we'll add this. Just add a single instance of that character. And we'll try again. We'll see there's a bug. Should not get here, only processing kana. So what we'll do is we'll say if not stir cmp entry dash kana this, then we're going to treat it differently. We'll say kata total plus plus. Okay. And otherwise we'll do the rest. Now this is in a loop, so we could probably just do a continue here. Let's try that again. Okay, let's see what the output was. Okay, this is close. We do want this total line here, but I think what we do also want, we want another line above it, which indicates the character. And let me pause the video because I'm getting some lag. Okay, I think I fixed that. So let's actually start writing the expected test out. So we will just edit this, and we'll put this in here. There is no hiragana. So I don't know if I like the fact that it prints 0 here. It's probably going to be the easiest way to implement it. But let's see. Oops. There we go. I suppose it would be nice to not print anything. So let's try that. Let's see what happens. So I have edit kana stats util. And so we're going to have to edit that. We're going to have to fix print kana stats line. Then yeah, we will have to change kana stats line. We also have to change oh, this is actually not causing a problem. Oh, because we're skipping hiragana here. So I think what we want to do is we don't want to look for katakana in this case. So if not cmp stats.li.kana compared to then in that case, we're going to do something simpler. We're going to say print kana stats line, and then we will give it what? We'll give it stats.l. So let's I kind of want to put this into a separate variable. We're using it quite a lot here. So we'll do struct stats entry, we'll call it hira. So I entry equals stats.li, right? And we'll replace this. Replace that with I entry. Okay, looks like that worked. Let's indent this properly. Oops, didn't work. And then I entry count, cut entry count. There. And let's also fix this line. There we go. Print kana stats line is so we're going to give it I entry dash kana and 2, and that's the width, the number of terminal cells that it consumes, and the count is I entry dash count, and then so this actually looks a whole lot like this, but it just is missing the katakana entry. So why don't we do this actually? We'll say we'll actually use a separate value. So we'll do kata count equals 0. Start at 0. And so then we will basically do this. If this is true, then we're going to get the kata entry. Actually here. If it's not hiragana, then we continue. Okay. Then we can do int is chong equals all right. And not is chong. Okay. So maybe what we do want to do is we want to like make code point range return this value. I'm going to skip making that prettier. I'm just gonna I'm gonna include include the 0 count for the cholong here. That's fine. And so what I'd like, let's look for code point range. We probably just want to include an extra thing there. So we'll go to edit chars.h and fine. Where is it used though? Edit hk.c 40 ranges. Okay. Kind of stats, and chars. Okay, so I think that we would like to okay. I think I like it better without the underscore there. So let's go to kana stats.c, where we're using code point range a lot. Oh, we didn't actually have it return that value. Let's fix that. Let's see. If stir cmp c 0, then we say return code point range. Okay. Now this is let's see, what is that value? Can we just put it after this? It would have to be greater than this character in Unicode, then it would be okay. So we can do printf, oh no, xdump -c, and we'll give it that and that. 83b6, 83bc. Okay, it works. So, okay. But it's kind of hard to reason about, so maybe we just want to put it first. Oh, I'm using spaces here. That's not right. Why am I using spaces for indentation? Code point range get log chars.c. Unfortunately, I added it in a previous commit. Oh, but I can fix that, I guess. I'll fix that later. So code point range. Okay. So that means we can go to kana stats and check this case code point range. All right, good. Okay, now we can switch to code point range. Case kana. All right, that means we can continue. Great. Code point range. Okay, so doing better now, and we continue in those cases. If we get code point range then we're going to let's see, if it is hiragana, then we're going to calculate the katakana thing. So we have entry, and okay. All right, that's good. And what is, we have other too. Oh, but we shouldn't have other, if I understand right. We should not have other at all. And case code point range. And this is where we say kata count is 0. All right, and break, and then we have a default, and this is where we have a bug. Unexpected char. We do I entry dash kana. Okay. Good. So then, if it's hiragana, then we do this. We get the count, kata entry, kata count. Not iEntry.count and not kata count, then we have nothing to do. Otherwise, we do kata count. Okay. Now this might be better as a separate function because we use this value here. Oops, just noticed this problem. Stats.li. Okay. I don't think we need this anymore. Okay. And katakana. Okay. So we can make that a separate function. We'll do uint64t kata count. for hiragana, char const hira, right? And we'll pass it the stats map, struct stats map const stats. All right. I want to choose a function name that's simple but doesn't overlap with this thing, kata, this count right here, kata count. Kata count for kata count of, I guess. All right. So now we can take these two declarations. They're only needed in this function. And we can take this. And then we do return I and, let's see, return kata entry dash count. Okay. And also we have I entry here. We don't need that. We want to call it hiragana. And hiragana. Right, hiragana, katakana, copy that. We search for it in stats. Right, and katakana, okay. Katakana. Okay, everything's declared in here that we use, so I think that we're done writing it. And now we can just do, we can just call it here. Kata count equals kata count of, and we give it the stats map and the kana there. Okay. That looks good. So if it's katakana, we don't really care about it. If it's hiragana, we set the katakana count. We look by looking it up in the map. If it's chonkigo, then we set the kata count to actually I entry dash kana and the oh, I guess we need this hira count. Hira count equals I entry dash count, right? Okay. And this means hira count is 0. Right. That's kana count and not count and kana count. Then we continue. And then we can do count. Hira count there. Okay. Right, that looks good. Okay, and I think that this would be a little more elegant if we use, if we went like this, set it to 0 here, and we break out here, and we don't have to use continue actually. And actually, maybe we can just say, oh, but then that's kind of confusing, because this does not really mean that katakana count is 0 here. So why don't we go ahead and undo what we just did. Okay. Now let's try this again. Kata count of. Kata count of. Okay. It's actually being used. Kata count. Kata count equals I entry dash count. Okay. Try that again. Kana. Kata count of. Oh, I have to make it static because there's no prototype for it. Okay, great. Great, so we support that. Now I kind of wonder if we should add some more tests for this particular character. So we can do kana stats test. Right. Chonkigo. with others. All right, and let's get rid of this. Go with others. Okay. So let's make temp test input, and we'll do ah, e, u, and ah, e, u. All right. And yeah, this will just mean that we have some other characters in the input, which kind of makes sure that we don't have some trivial logic to count. So we'll do make. In other words, make sure that we're not using some hack that's inspired by test-driven development. And then the output is most likely going to be correct. Okay, so we have 1 of IU and of katakana, hiragana. We have 6 of the chon kigo. And okay, that looks good. So great. Now what we want to do is we want to make sure that we support these other characters, these somewhat uncommon characters. So we want to we want to support wool, which is actually not uncommon. It's very common, and va, and the wagyu with dakten. So let's go ahead and go to kana. Let's see, kana stats. Edit kana stats test. We'll do start test file, and we'll say other characters. Let's just do wool first. Wool. All right. With others. Oh, what happened? Why is this file no longer existing? Did I rename the test? Test input, kana stats test. Oh yeah, I renamed the test. Okay, so test input slash kana stats test dot c dot cho. Okay, so I'm removing the underscore from the test file name as well. Oh, it's already there. Git rm chonkigo with others. Chonkigo. That's confusing. I thought that it was that I just created that file and the test passed. Cat kana. Let's look at the expected test output. Make sure at least that exists. Stats test dot z dot chonkigo. Nope. Anyway, we don't need this kana stats test dot z dot cho underscore. Let's do a diff. They should be the same file. Oh, I see. I see. That's what I did wrong. Okay, so we have underscore is what we really want there, and then we have this chon without an underscore, which is actually the chonkigo with others. So I kind of screwed up. Kana stats test. I guess I'm confusing like save as with save copy in Vim. That must be what I'm doing wrong. Chonkigo. Okay, so that is underscore chon. That's what we really want there. So what we want to do is we want to take this and we'll say test input slash kana stats test c dot cho on kigo with others. And then we'll do something similar here. I'll take this. All right. Now this is not going to work. Chon Kigo is as expected. Okay. So that test output is correct. Now we'll make the test again. Go with others. All right. Test output. Okay, that's correct. So let's copy that in place. And test will not passing yet. Kana stats test will. Okay, here we go. Kana stats test. Okay. All right. And we'll also support capital or katakana, and then we'll do a make all right, test out. Okay, that actually worked. I'm surprised that that worked. It even caught the wool there. But I thought that this will not include any wool. Oh, it's included as this. It's included with a different input code, right? XX something. Where is it? XXL is wool. And that's not what people should normally use to type it, but it is here. It is as given as an alternative. So, okay, that already passes. That's good. And we don't need to include it explicitly in that sense. So now we can do kana stats test, edit kana stats test. So now we want va. Okay, edit kana stat. Let's run that. There. Okay. So let's actually just copy that from over here. Here. Oops. There we go. Let's all right. Now let's edit the expected output, and we will have this. Oops. We'll have that. Hiragana count is nothing. Katakana count is 1. And this does not have a hiragana equivalent, if I remember right, so it's probably going to cause an error when we try and try and run it. It's going to cause like a bug error. So okay, let's see what happens here. Okay, it doesn't include it. So we will go ahead and do this, and now it will cause a bug error, I believe. Yes. Unexpected kana. Okay. So instead of doing this kigo thing, I think what we want to do is we want to say this is like a katakana special, which means that there's no hiragana equivalent. Katakana special. Here. Okay. Now let's go over into chars.h and fix that. Special. Okay. Chars.c. And we'll say katakana without hiragana equivalent. Let's see. Okay. Let's open chars.c. Range katakana special. All right. Then we want to return it for if stir cmp c va. Oops. Okay, let's get that again. Copy and paste, because I don't believe I was able to input that with my existing input method. I think it's kind of an oversight that I didn't include it. Okay, 0. Okay, but I can check to make sure. How about git grep or grep? Oops. Let's copy and paste again. Oh, it's not working. There we go. And look in my previous input method editor. Okay, it's not there. So yeah, I am stuck to copying and pasting for now, unless I want to go fix it, which I don't think I want to do. Okay, that worked. Great. So now we want to include the wagyu here. Include fa. All right. But I think we can amend this. This is a good checkpoint. And now wagyu with dakten. Okay. So we want these. Let's go to kana stats test. We'll do this again. Wagyu with dakuten. Okay. Let's run the tests. Get the file name that we want to populate, and we'll let's copy and paste it here. Oops, it didn't work because it's a different Vim instance. How does everyone else handle like multiple Vim instances and copy and pasting? I just don't know. All right, there we go. And let's just add some more. Okay. And we can also do like this. Oh, let's just keep it as that. Okay. And see what happens. Test out. Okay. There's no katakana for these? Okay, that's wrong. Something happened. So wagyu with dakten. Oh, I see. Because the hiragana is not really supported for this. So let's get rid of the hiragana versions of that. We can't do that until we support like we can't support that until we handle composition or the dakten composed character, which we don't really support now. So let's just say we want that. We want to move that over here. Let's do it like this. Okay. And right, so we'll take these. We're going to use these here. Oops. go. Okay. Good. That is what we want. So let's make that. Stats. Oh, we do want to fix the input, don't we? Test input. Okay. Let's get rid of the hiragana versions of these. Okay. Diff. There is no diff. So let's do cat. All right. So it's not correct. Okay, so let's make these as katakana special as well. Edit chars.c. Okay. Let's look up katakana range again in Wikipedia. Okay, it's right here. And we are, these special ones are down here, I guess. Oh, and we didn't include vo. Did we include that ever? I kind of think we didn't. Is that in the romaji.c file anywhere? Oh yes, it's there. But yeah, and va. Okay, yeah, that's why there are 4 when I expected to see 3, because va is counted along with all these other ones. So we actually want these to this range kind of. These are all together. And prolonged sound mark is there. So 30 FC, 30 B. Okay, so FA. Okay, so these are all contiguous too. So this makes sense. So we want to kind of start here and go all the way down here. And so it starts with va and ends with dash. Okay. And that goes after k right there. So say if it's less than this, then that means we can return special. Return special. Okay. Now that should work. Let's see what the output looks like. No, that didn't work. Oh, that's because we actually have to include it over here. Okay, no katakana entry for that. Okay, what is that about? Oh, because this is, okay. Yeah, that's not going to work. That bug check is not going to work for these. So maybe we should make this a separate flag, wagyo with dakteng. Because these are obviously special. Apparently they didn't include hiragana equivalents for these. And you only can make them with composed characters, and so we don't really want to include them, honestly. Git grep wagyo with dakteng. Where is that actually being set? It's being set here. No kanji wagyo with dakteng. Okay. So we're also using this as a flag. Wagyo with dakteng. Wagyo with dakteng. So we need to fix this. We need to change the way we've been using it. The thing is, yeah, maybe this doesn't make sense to actually make it configurable. Okay. Okay, so maybe what we want to do when we convert it to katakana is we automatically compose the characters. So if we check for this in decomposed form, and if it's in decomposed form, then we convert it to composed form. We can definitely do that. It's kind of icky, but it works. or when we're reading the file, we can convert it. So, yeah, I'm not sure how I want to handle that. I'll go with ducting. So the thing is, it's just a bug here, right? It's a bug in where does the bug? It's no katakana entry for that. Okay, no katakana entry. Okay. So if it doesn't have an entry, we can just return 0, I suppose. Um, we can look for the decomposed ducting in the character, and if it's there, then we don't do anything. We just kind of skip it. I'll go with ducting. Or over here, we can kind of pre-filter it out when we're populating it, collect potential mappings. So we can say if, okay, input mapping. So we can do this. Char const conv equals that. Oops. And conv. And we can do if conv has that character in it. So if it's a composed character, then we don't do anything. So if conv strs and cmp size comes last. Okay. Conv and +3, and we look for the composed ducting. Okay. So char pound define composed ducting. Okay. Now is that in here somewhere in this page? It is not. Let's just copy it from over here. Oops. Okay. Okay, it is E38299. XE38299. Okay, so then we can say conv3 and composed ducting and size of composed ducting. I believe that's will work. The size of in that case should work as we expected. Oh, but this is a string literal. Let's just so it's going to be null terminated. So let's just hard code the 3. If that, then continue. We don't want to handle that. Size of okay. All right, let's try that. I'll go with ducting. Let's see what happens here. Okay, that is what I wanted. So we got those supported. Maybe it was too much work for the benefit, but I guess that's okay. Maybe we don't really want to have this as separate. Do not support composed. Let's see. Not support. Not support characters or kana that used or that need composed ducting. They should not occur in practice in real text much. Okay. Right. Let's see. Of course, I just added a comment, so it should not really change anything. Okay, good. And yeah, let's see what that looks like. Oh, we don't want to add that define line anymore. And okay, so that's a good checkpoint. So now what I'm probably going to do is I'll try running this on some real text. Icon from, okay, so we'll do new sort kana stats less. Okay, very good. And so what I really wanted to do this whole time was check how often wa occurs, and it looks like it's 0.1% of all the characters. So assuming that we have 25% kana in the text, so we don't support those sutegana sequences like kyo and kyu and kya, sho, shu, sha. We don't support that yet. We just ignore the second character. We just count the first one. For my purposes, that's enough. So I might not continue working on this because I've gotten exactly the information I want. And so now I'm going to try and figure out if I want to give this wa a more common, like a single key sequence in order to type it, like maybe just W. In order to do that, I got to figure out how much kanji appear compared to this. So if this is just one character, one key to type, then it's going to displace 40 kanji or so. And So I need to see whether or not the 40 least common kanji in the code in the like higher the ranking, do they occur as much as this or less than this? And I did do calculations like that before, so let me pause, let me open that up. So I think that rather than handling that right now, I'm going to stop the video. I can't find the file. I think it might be on a separate computer, and I'll do that analysis offline. But for the most part, it looks like wa in a random text appears 0.1% in every character, assuming that we have 25% kana for every kanji. And yeah, let's just say that's that, and I'll talk to you later. Thank you for watching.